Hey everybody, this is Dr. A here, and in this video we are going to be giving an introduction to linear interpolation and looking at one numerical example of it. So what is linear interpolation? Well, this is the mathematical process of constructing a linear relationship between two known data points and using this relationship to approximate values that are in between these two known data points. Okay, so you want to write this down. Remember, as we all know in math related material, we need to write it down. The best way to learn it is to write it down. Don't just watch and listen and think you can understand it. Write this down in your notebooks or on a piece of paper, something. Okay, so so this is what the basic idea of linear interpolation is. Now it turns out linear interpolation is mathematically very similar. Some people would even say it's the same as direct proportionality, similar triangles, and point slope formula. The reason why we can kind of say that, we can say linear interpolation is mathematically basically the same as direct proportionality, similar triangles, and point slope formula is because think about the basic definition of what we just wrote down for linear interpolation. We are building a linear relationship between two known data points, and then we're going to use that relationship to determine values that are in between those two known data points. And when we are looking at direct proportionality problems, or from geometry when we're applying similar triangles to build a relationship, or from algebra when we're using point slope formula, we're kind of doing the same thing, pretty much doing the same thing with direct proportionality, similar triangles, and point slope formula. We are building some type of linear relationship between points and then determining intermediate values using that relationship. So it turns out what you do with linear interpolation, you can pretty much do, you can apply direct proportionality, similar triangles, or point slope formula to get the same result as you would with linear interpolation. Okay, it's just linear interpolation seems to be more convenient for tabulated values. Okay, so let me draw a little sketch out to conceptually show what we're doing. Let's say that we have a set of coordinate axes, okay, and let's call them y and x, and let's say we have 2 points here that are somewhere on this coordinate axis, on this set of coordinate axes, and let's say this point is defined by a comma b, and this point up here is defined by c comma d, okay? So with linear interpolation, what we're doing is we're taking these two known points. Let's say these 2 points We know A comma B and we know C comma D, and we're putting a straight line, we're building a straight line relationship between these 2 points. So let's say we're building this straight line relationship between these 2 points, and then using that straight line relationship, we can then determine information about values in between these 2 points on that straight line. That's the beauty of it, okay? So that's the basic idea of it if you want to visualize it graphically, okay? So let's go ahead and jump right into an example, okay? An applied example of this, all right? So let's say example, and you know we always like to start with the word given, or given information. And so we're going to say, for the data below, we want to use linear interpolation to compute the value of y. Okay, so this is all given information right now. So let's call this data set, maybe you call this capital X and capital Y. And let's say that we know the points 1, 2, and we know the point 5, 4. And we want to find this value of y here, little y, that corresponds to an x value of 3, okay? So this is our given information. Let's go ahead and write solution here, okay? And so let's go ahead and make sure we know what we're looking at. The, quote, known points are what? Well, 1, 2 and 5, 4, okay? So this is a known point right here, 1, 2, and then the other known point is 5, 4. And so what we're looking for is this value of little y that's in red here that corresponds to an x value of 3, all right? So let's go ahead and build this relationship. Now, here's what I do, and you know, you may find other people or other videos that maybe use a slightly different technique of organization, but this is what has always worked for me. So under solution, I'm going to rewrite our given table here, all right? And here's that y value that we're looking for, all right? Now, what I do that has always helped me is I'm going to go with a different color now. I'm going to go with green. I like to draw arrows on the table that I'm given, and that helps me figure out how to subtract and divide and build my relationship. So watch this. I'm going to start on the x side right here, okay? I'm going to say 5 minus 1, okay? So I'm going to write over here 5 minus 1, okay? And then I'm going to say divided by, and then I'm going to draw another arrow, 5 from 5 and point it at 3. So I'm going to say 5 minus 1 divided by 5 minus 3, okay? And then I'm going to say equals. And then I'm going to follow that same pattern on the right side, on the right column, okay? So watch this. I'm going to start with that bottom number, 4, and I'm going to say 4 minus 2. And I'm doing that because when I first started building this relationship, I did the bottom number 5 minus the top number 1, okay? So on the right side, I'm going to do 4 minus 2, and I'm going to make that the numerator. And then as the denominator of the right side, what do you think I'm going to do next? I'm going to do 4 minus y right here, okay? 4 minus y. And now if you look at this relationship, this is that relationship that I was talking about. You build a relationship. you have a lot of numbers here and you only have one unknown, and that's that value you're looking for of y, okay? So now you can just easily manipulate things. You can clearly see that this becomes 4 over 2 equals 2 over 4 minus y, okay? And we can, see 4 over 2 reduces to 2 equals 2 divided by 4 minus y. Right now I'm just kind of showing some simple algebra manipulation. So we have 4 minus y equals 2 over 2, which of course is 1. So 4 minus y equals 1. And then we can rearrange that and we get y equals 3. And that is our answer. So let's discuss kind of what we did here, all right? What we did was in building our linear relationship, what we did was we looked at a change in x values divided by another change in x values equals a change in y values divided by another change in y values. I forgot to draw my other arrow here. Here you go. That was my arrow for 4 minus y, okay? And so what we've done here is kind of this tabulated form of looking at a rise over a run, but it's rearranged a bit, okay? And what we did by default with these numbers here is we kind of built into it a slope factor, okay? So again, a slope is the essence of a slope is built into this process, all right? And once we set up these two fractions and we equated them, we rearranged and we solved for the unknown value of y here, and it came out to be the number 3, all right? Now, again, there are other ways of setting this up. There are other ways of organizing this. This isn't the one and only way of doing it. This is just the way I always did it that helped me visualize things, work left to right, and then set up my fractions like that. So that's going to conclude this particular video and example on linear interpolation.